Hey, so welcome to a basic tutorial on how to get basic locomotion on a 2D scene. So this is going to be a 2D project here. We're just going to get you started on something nice and easy, similar to something that I started out when I first learned how to use these programs. Um, so let's get started. We're going to create a basic scene. So right-click our hierarchy on the left here. We're going to want to create a sprite, and we're just going to name this sprite platform for organization. And inside here, we're just going to use the UI sprite model and just change the scale on the top right here. So the X we're going to make, let's say 25, and the Y 10. So it doesn't look the best. You're going to need to, like, if you're going to use this, you want to draw your own platforms. This is just for examples here. We're going to make this, let's just make this a green, represent grass, and just kind of copy it like this. So we're going to try at the end of this series, we're going to try and get it to move and jump on these platforms. All right, it's not going to be a long series, but bear with me on this. So next we're going to create one more sprite here. So create 2D sprite, and then we're going to name this player. And we're also going to use the UI sprite as well, but instead of 25 by 10, let's just do 5 by 5, just so we can kind of see it here. There we go. Okay, so now that we got our scene set up, we're going to want to create a script. So go into project, go to create, C# script, player controller, and make sure you don't do any spaces inside when you're naming these scripts, because that can really mess up your compiling errors, and once you do that, it might be a little confusing to figure out why it's not working, even though everything looks like it should be working. So once it's all compiled, we're just going to double click it here. It should open up into Visual Studio, and that's where we're going to start learning our first code, or one of our first codes. So once we get inside here, now there are 4 basic variables I want to go through in this video. So we have an int, which is a basic number, so that would be like 1, 2, 3, 4, no decimal zone. Ints can't do decimals. A float, which is similar to an int, but it can do decimals. So it'd be 1.1, for example, 1.2. The thing about floats, though, is at the end of every decimal number, you have to put an F, so it's automatically registered under float, because Unity defaults to integer, even if you put a decimal, which is a little weird. Next, we have a bool, so that would be a true or a false statement. It can be very useful for certain codes. And lastly, a string, which is basically text. So it could be a name like my name is whatever. Strings are something we're not going to be using, and a bool maybe, but we're mostly going to be focusing on a float today. So we're going to want to create a public float, and we're going to call it move speed. And then we want to grab something on our player controller. We're going to be using one of Unity's default physics things for 2D. We're going to call a public rigid body 2D. We're just going to name it RB in that reference there. And now there's 3 types of different update functions, and I'm going to go through them with you. So we have void update. So this is a function that you don't want to use all the time, but use it for stuff like player input. And maybe if you're running something that has to be checked every frame, but usually I only use it for something like player input, because it checks every single frame, and that could be very costly to your CPU, especially if you're doing a big game. There's also fixed update. So this is good if you're doing fixed coding. And if we want to get more complex based on how smooth our player is moving, we might use both update and fix update. Update for input, fix update for moving the character. And then there's late update, which is more commonly used on cameras. So the camera, for some reason, it makes the camera follow the player smoother. Next, we're going to want to, so right now we're just going to use void update. So void update, we want to call this every frame because we're going to be calling it input. So I'm going to do a basic check here. So a basic if statement, if input, get axis, horizontal, and exclamation point, so that means not. So whatever it, so if you put an exclamation point then an equal, it's whatever 0 isn't. So it could be 0.1, 0.2, just as long as it's not 0, it'll pass this if statement, and then it'll call our function inside here. Now what get axis is it's calling the input that's already default to Unity. So horizontal axis would be AD, or the left arrow or the right arrow, basically, is what we're calling here. So if that's, and 0 is its resting state. So if that's being called, that means that one of these two buttons have been pressed, right or left. And once we call them, we're going to edit the velocity of the rigid body to equal new vector 2. Sorry, plus equal new vector 2. Move speed. And we're going to multiply it by input dot get axis horizontal, comma 0, because we don't want to edit the y-axis, because y is up and down. We want to edit left and right. My left, your right. There we go, and that should be all we need for a basic movement. There's a few things we want to do to our platforms here. So when we select all our platforms, you can do this individually or select them all. We want to add a box collider 2D here. So our physics engine doesn't just pass through these squares here. And on our player, we're also going to want to add a box collider. And we're also going to want to add a rigid body 2D that we brought up in our code. So we just click and drag the player here. Oh wait, sorry, my bad. We want to drag the code into the player as well. Now that's down here. You see how it's missing the rigid body down at the bottom right? Sorry, you can't see that. Right there at the bottom, it's missing it. So we're just going to click and drag the rigid body up here into the rigid body down there and make our move speed. We'll test it off at like 1. Right there. There we go. Okay, now when we press play, you should be able to, oh, that's really fast. 1 is too much. But it works, which is the wonders of coding. Okay, so I'm going to, just for reference sake, I'm just going to make it 0.1. I'm just going to cut that down by a lot. There we go. Let's see how that works. It's a little slower. Kind of get stuck in the corner there. So you kind of get faster as you go with this code. Sorry about that. We had a little error there, and it's pretty common when you're coding. So if we hop back into our code here, we're just going to want to delete the plus sign in the velocity. And then when we come out of it, we'll just need to up the number here. So down at the bottom, move speed needs to be 4 instead of 0.1. All right. So we press play here. We're going to notice that it's a lot smoother. You're not flying off a map like we were before. And overall, it's pretty comfortable to use. So now when we jump back into Unity, I want to do one more thing. I want to have the camera follow the player, and then we're going to jump into our last part on the basic movement, which will be jumping. We'll get jumping into it, which won't be too hard. And there you go. So now under here, we're going to need to reference our camera. You always need to reference something that you're editing, or you can't edit it. So we're going to do a transform, and this is the movement of it. And then we're just going to do camera here. There we go. And it's going to be a separate function. So we're going to do a void late update. Like I said earlier, it's for smoother. It helps have smoother movement with cameras. So this time we're going to do a camera dot transform. So we already have the transform. Sorry, camera dot position is going to equal vector 3. Even if it's a 2D space, we're going to use a vector 3 dot lerp, and I'm going to show you exactly what that does. I'm just going to do that real quick, and then at the top here, underneath our transform, we're going to make another float called cam speed. Just equal it to 1. This is a default value, so instead of when you make the thing, it goes to 0. This is just going to make it to 1 automatically instead of 0 when you exit out. And basically what a lerp does here, so when we put our mouse over it, it says vector 3a and vector 3b and then t. So vector 3a is our first one, so we normally will use the camera transform, and we want to lerp it between the player transform because it's following the player transform. And all it does is create a smooth line between the two. So it'll follow smoothly instead of just jumping to the player position, which most code usually does. So we're just going to want to do camera.position and then transform.position. So transform.position is going to access the player object which the script is on. And then we're going to comma cam speed. We press save and save, and then we're also going to want to add something at the bottom here. Camera dot position, because this is a 2D space, and Z should not be edited too much. It's going to equal new vector 3, because we don't want to edit X and Y, because like I said, it's a 2D space, so we're just going to do camera dot position dot X, camera dot position dot Y, and we want Z to be -10, so it's backed up behind all the other stuff. Let that save, and then that should work. We just got to go into our player here, again at the bottom, and just drag our camera on the top left down to the bottom right there. And that should be it. Just press play, and it should follow our player here. There we go. So right now, it's following pretty sternly, so I'm going to go down to cam speed here and knock it down to 0.1, see how that works. See how it's kind of dragging behind now? If we lower that even more, 0.01. Now it's smoothly following. It's a little jittery, but that could be worked out, like I said, if you do fix update. And you have, because we're monitoring physics here, but this is just basic. And yeah, there we go. That is our first part here. I'm going to join you for a second part pretty soon. And we'll see you in the next video.